Okay, so last lesson we came across the equation n, refractive index, sine theta 1, so sine of the angle in material 1 divided by sine of the angle in material 2. Or I said sometimes it's easier to look at it like n2, so refractive index of medium 2, divided by the refractive index of medium 1, which is usually air, which is 1, is sine theta 1 over sine theta 2. So we're going to do some examples of this before I let you guys have a go. So first of all, worked example 1a. So we've got an angle of incidence of 40 degrees and an angle of refraction of 25 degrees. Now remember, it might not always give you the angle of incidence and the angle of refraction. It might give you the wrong angle, so it might say the angle there, and you'd have to work out the angle of incidence from that. But in this case, we're okay. So calculate the refractive index of the second medium, so n2. So remember, this is why I think I like looking at n2 divided by n1 equals sine theta 1 divided by sine theta 2. Because it helps us out thinking about the different materials. So n2 is what we want to find out. We want the refractive index of the second medium. n1, if it doesn't tell us, we always just assume it's going from air into something else. So it's just 1. Sine theta 1 is sine 40, and sine theta 2 is sine of 25 because it's the angle in the second medium. So we put in the numbers. So n2 divided by 1, which is just n2, is sine of 40 divided by sine of 25. You just put that into your calculator and you end up with 1.52. Okay, I'd like you to pause the video and have a go at part B before I go through the actual answer. Pause now. Okay, so hopefully you've had a go at this. So part B, find the angle of incidence in the first medium, so in air. So again, we're going to use this equation, n2 over n1 is sine theta 1 over sine theta 2. So n2 is the refractive index of the second medium, which we're told in the diagram is 1.55. n1, again, it's just 1 because it's air. Or sine theta 1 would be sine of that angle that we want to find. And sine theta 2 will be the sine of 20. So we put those numbers into that equation. So 1.55 divided by 1, which is just 1.55, equals sine theta 1, which is what we want to find, divided by sine of 20. So sine theta would be 1.55 times by sine 20. And so sine theta comes to 0.53, but we haven't answered it yet because that's just sine theta. We want to know what the angle is. The angle is inverse sine of 0.53, which is 32 degrees. And this is a little bit about what I've already talked about already. Strictly speaking, the refractive index depends on both the materials which meet at the boundary. So medium 1 and medium 2. So it's just as I said, n2 over n1, and n1's usually just 1 because it's usually just air, equals sine theta 1 over sine theta 2. And what I've already written there is if the second medium has a bigger n, which usually it does, because we're going from air into perspex, light bends towards the normal. And the bigger the n, the more it bends. And the opposite is true. So if the second medium, for example, if you're going from glass to air, the second medium has a smaller n, it bends away from the normal. And again, the smaller the n, the more it bends. I'll leave that there for a second for you to write that up. And now we're going to look at one more example before I get you guys to do some of these. So other factors affecting refractive index. So the diagram below shows the electromagnetic spectrum. Complete the missing parts. Now I'm sure you can do this yourself. Radio waves, sing the song to yourself. Radio waves, microwaves, infrared, radiation, visible light, ultraviolet, X-rays, gamma rays. You got my singing there. Right, so that's your electromagnetic spectrum. You should know that by now. Okay. And we know also that each color of light has a different wavelength or frequency. So red has the longest wavelength and the lowest frequency. Remember, as one goes up, the other goes down. And violet has the shortest wavelength, the highest frequency. The wavelength of red light is about 700 nanometers, and the wavelength of violet light is about 400 nanometers. Just very interesting. Right, so worked example 2 is slightly more complicated. So a ray of light from a tungsten filament, so that's just a light bulb basically, is incident on a glass prism, as shown below. So we've got the light going in as white light, but it's getting refracted out and it's basically creating a rainbow. Okay. So the refractive index of glass is 1.53 for blue light and 1.51 for red light. So there's different refractive indexes for different colours of light. If P and Q represent the ends of the visible spectrum, which is the blue end, and then we want to calculate the angle alpha. Okay, so we know now, because I wrote it slightly earlier on, that the bigger the n, the more bending it does. Okay, so in this case, P has done the most bending. So P must be the light with the highest refractive index. So P is going to be blue. And Q would be red. So red, blue. Okay. And that's just because the bigger the refractive index, the more bending. So we know that P is blue and we know that Q is red. And we want to find now the angle alpha. So the alpha is basically the angles in the difference between the angles of refraction of the red light and the blue light. So difference of angles of refraction of red and blue light. Okay. So what we want to do is we want to find the angle of refraction of blue lights, we want to find the angle of refraction of red lights, and then we just want to take them away from each other. So let's look at blue light first of all. So it's going from air, well, we're not told that, but we're assuming it is because it's just a light in air, into glass. And the refractive index of the glass for blue light is 1.53. So remember, N2 is second material, N1 is just air, so 1. Theta 1 is the angle of incidence, but remember I said watch out for this. It's not giving you the correct angle. We actually want this angle here that I've marked, which will be 90 minus 30, so 60 degrees. So theta 1 will be 60 degrees. And we want to find theta 2 to be able to answer this. So question 1. Sorry, that should be sine theta 1. Sine 60. And sine theta 2 is what we want to find out, so we can find theta 2. So use our equation. N2 over N1 equals sine theta 1 over sine theta 2. The difficult part is remembering is 1 or 2 above or below. So 1.53 divided by 1 is just 1.53 equals sine 60 divided by sine theta 2. So sine theta 2 will be sine 60 divided by 1.53, which comes to something like 0.566666. So theta 2 is the inverse sine of that. Just keep it in your calculator, do inverse sine of answer, which comes to 34.5 degrees. So that's the angle of refraction for blue light. Right, now we need to find the same for red. So N2 for red is 1.51, N1 is just again for air is 1. Sine theta 1 is again sine 60 because it's the same. And sine theta 2 is what we want to find out. So we're just doing exactly the same thing, just with slightly different numbers. So 1.51 divided by 1 is 1.51. Is sine 60 divided by sine theta 2. So sine theta 2 ends up being sine 60 divided by 1.51, which is, let me just do that quickly, 0.573, blah, 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 blah. So keep that in your calculator, do inverse sine of that. So theta 2 comes to 35 degrees. So we still haven't finished yet because we need to know alpha, which is the difference between those. So alpha is 35, take away 34.5, which comes to 0.5 degrees. And that is your final answer. Okay, so I'm going to get you guys to do some questions similar to this. So I'll just read you a 5-5 task.